Hello world, today you guys voted to have me talk about this. Speed of light was broken. Share your thoughts, explain it for people who have no idea what this means, if proven true. From Jolly Joey 101 in Bayamon, Puerto Rico. What could it mean? Okay, the measurement you are referencing happened at CERN, and most of you have probably heard of CERN before. They're over in Europe. They have the world's largest particle accelerator called the LHC, the Large Hadron Collider, that a couple of years ago when they turned on, some people were worried that it would create a black hole that would destroy the planet. Luckily that didn't happen, and the LHC went on to do some incredible science, still does some incredible science, but the incredible science we are talking about today actually did not involve the LHC. The incredible science we are talking about today happened during an experiment called OPERA, which stands for Oscillation Project with Emulsion Racking Apparatus, in case you were curious. Now, the point of the OPERA experiment was and is to study something called neutrino oscillations. And so I went to the Wikipedia page for neutrino oscillations, and the whole thing was just completely over my head. They were talking about the nuances of quantum mechanics and lepton flavors. I don't know what that means. But that's okay, that's not directly relevant to what we're talking about today. I did understand enough to give, I think, a basic explanation of how they measured a neutrino moving faster than the speed of light. So the first thing you have to understand is, what is a neutrino? Now again, there are a lot of nuances about what makes a neutrino that I don't fully understand. Apparently they can spin in different ways. What I do understand is that neutrinos are subatomic particles that are smaller than atoms that don't interact with most normal matter. What that means is that they can pass through things as though those things weren't there. Also, neutrinos do have mass, but a very, very small amount of it. So even when just a little bit of energy is applied to them, even just given a little push, that they tend to go at the speed of light. So CERN, as a part of this OPERA experiment, fired a super duper intense beam of neutrinos underground from their headquarters in Switzerland to a laboratory in the middle of Italy, approximately 455 miles away. That is about the same distance as from where I am sitting right now in my apartment in Lincoln, Nebraska, to Denver, Colorado. But instead of the 6 days and 16 hours Google Maps tell me it would take to walk that far, a neutrino going at the speed of light would get there in approximately 2.4 milliseconds. That's what CERN expected to happen. In fact, they didn't even expect it. They knew it. They took for granted that that was what was going to happen, because neutrinos travel at the speed of light and no faster. Nothing travels faster than the speed of light. That is the universal speed limit, except when they looked at the data, when they looked at the measurements that were measured with the precisest of precise precision equipment, it certainly looked like those neutrinos got there 60 billionths of a second too fast. Which is to say that it certainly looks like these particles traveled faster than the speed of light. And that would be a very, very big deal. Now, before you get your nuts tied up in too tight of a scientifical nerdgasmy bunch, let me just say there is plenty of doubt. Even the researchers at CERN who may have made this discovery are very, very skeptical. Scientists the world over are poring over the data, looking for any potential flaws in how the experiment was conducted or how the data from the experiment was synthesized, and the results can be confirmed if and only if no flaws are found, and if and only if repeat experiments show the same results consistently. Those are two extraordinarily big ifs. But should the criteria for both of those ifs be met, then humanity has, as described by some scientists, made the most important scientific discovery of the last century. Throughout history, new discoveries or ideas have completely changed scientific paradigms. For example, when Copernicus had the idea that, hey, maybe the sun doesn't orbit the Earth, maybe the Earth orbits the sun. Or when Albert Einstein began thinking about light and how the scientific understanding of his day couldn't adequately explain its behavior, so he came up with the theory of relativity that E equals mc squared that explained it, and also led to the realization that splitting atoms could lead to a huge release of energy, which led to nuclear weapons and nuclear power and the nuclear age. If neutrinos are, in fact, traveling faster than the speed of light, much of the Einsteinian model that's dominant in physics today could be turned on its head. As it turns out, E might not always equal mc squared. We could be at the beginning of a brand new scientific paradigm. So I'm no scientist. I have no idea what real-world applications discoveries made in the wake of this discovery could lead to. I mean, I've heard a little bit about maybe time travel being possible. That would be cool, but I have absolutely no idea if that's accurate. Don't take my word for that. What I do understand, though, is that this could be a turning point in our scientific understanding of the universe and how it works that happens less than once in a lifetime. And that's pretty cool. If this discovery does in fact turn out to be a legit discovery, how do you think it ultimately will affect our day-to-day lives? Post a comment. Also, please don't be a zombie. If you like what you just saw, if Dan put you in a state of awe, subscribe to him and click the orange button. It really means something. If you do that, that'd be really cool.